Welcome to aminacademy.com. In physics, regarding mechanical properties of fluids, let us do some solving problem. A hydraulic automobile lift is designed to lift cars with a maximum mass of 3000 kg. The area of cross section of the piston carrying a load is 425 centimeters square. What maximum pressure would the smaller piston have to bear? Here, pressure is same in both column. P1 equal P2. Therefore, P1 is force F1 by area 1 is F2 by A2. Here, 3000 kg, F1 is force is 3000, load is 3000 into 9.8 over A1. Area is 425 centimeter square is given. It is in 10 to the power of minus 4 is in meter square, which is equal F2 by A2. We have to find what maximum pressure would the smaller piston have to bear. So we have to calculate F2 by A2, which is equal, therefore, force P2 is by calculation of 3000 into 9.8 into divided by 425 into 4 minus 4 is 691.765 Newton. Here 10 power 4 comes into 10 power 4 Newton per meter square, which is equal .1765 and 10 power of 4 Newton per meter square, which is equal to 691.765 into 10 to the power of 3 Newton per meter square, which is equal to 691.765 kilonewton, because 10 power of 3 is kilo Newton per meter square, which is equal to kilopascal. That much kilopascal it can withstand pressure in smaller piston. Here, U-tube contains water and methylated spirit separated by mercury. The mercury column in the two arms are in level of 10 centimeter of water in one arm and 12.5 centimeter of spirit in other column. What is the relative density of spirit? Here, first we'll talk about water column. In water column, which is H1, is given as 10 centimeter and density of water is 1 gram per centimeter cube. For spirit column, H2 is given as 12.5 centimeter. Density of spirit is what first? Here Both columns are equal in equilibrium. Therefore, we can write H1 pressure is equal both sides. H1 rho 1 G equal to H2 rho 2 G. Here is cut both sides. Therefore, rho 2 density of spirit have to find, which is equal H2 over H1 over H2, H1 over H2 into rho 1, which is equal 10 by 12.5 into 1, which is equal 0.8 gram per centimeter cube density. Therefore, relative density is rho 2 over rho 1. Rho 2 is spirit, that is 0.8. Rho 1 is water, is 1, which is equal 0.8. There is no unit for relative density. Next question. Can Bernoulli equation be used to describe the flow of water through a rapid motion in river? Explain. No. The Bernoulli equation cannot be used because because this flow is rapid. Bernoulli's theorem is applicable only for their ideal fluids in streamlined motion. Since the flow of water in river is rapid, therefore it cannot be treated as streamlined motion. Therefore, the theorem cannot be used. The Bernoulli's equation theorem is used for only streamlined flow, but water flow rapid in river, so it cannot be used. Next question. Does it matter if one uses gauge instead of absolute pressure in applying Bernoulli's equation? Explain. We cannot use. No, that is, it does not matter. That means, does it matter? It's no matter for use of gauge pressure instead of absolute pressure in Bernoulli's equation, since it does not matter of if one uses gauge instead of absolute pressure in applying Bernoulli's equation, provided the atmospheric pressure at the 2 points where Bernoulli's equation is applied are significantly different. Next question. Glycerin flows steadily through a horizontal tube of length 1.5 meter, that is, length of the tube is 1.5 meter and radius is 1 centimeter. If the amount of glycerin collected per second at one end is 4 into 10 power minus 3 kg per second, that much kg of glycerin is collected from the tube which is flowing. What is the pressure difference between the two ends of the tube? Density of glycerin is 1.3 in 10 power 3 kg per meter cube. The viscosity of glycerin is 0.83 pascal second. Then you may also like to check the assumption of the laminar flow and the tube is correct. Now, because it's here that the length of the tube is 1.5 meter, radius is 1 centimeter, it is converted to 1 into 10 power minus 2 meter. The volume per second. Here, volume is, we know that mass per density. Mass is flowing through the tube is 4 centimeter, 4 into 10 power minus 3. Over density is 1.3 and 10 power 3 meter cube per second. Then, which is given as 4 divided by 1.3 in 10 power, this minus 3 go plus 3 go, that side is minus 3, 10 power minus 6 meter cube per second. This much volume of glycerin is flowing through the tube per second. Now, the given viscosity is given 0.83 pascal second. Now, volume formula is pi p r power 4 by 8 pi formula v equal pi p r power 4 by 8 eta l, where p is the pressure, r is the radius. This is the eta is given as viscosity and length of the pipe. Then from that we'll get P. P is by cross multiplying V into 8 eta L by pi r power 4. That by cross multiplying we'll get this relation. Substituting this P value, that values are given 8, V is 4 by 4 over 1.3 into 10 power minus 6, eta is 0.83 and L is 1.5 meter and pi is down, so 22 by 7, go up is reciprocal is 7 by 22 into R is 1 over R is 1 over 10 power minus 2, but power 4 is 1 over 10 power minus 8. By calculation of this, we get 9.75 into 10 raised to 2 Pascal. This much pressure is available in the flow of that glycerin in the tube. Now, we got the pressure, but the Reynolds number is 0.3. By using this calculation to the Reynolds number, it is 0.3. So the flow is laminar also, I can understand, because it is up to that the Reynolds number, by calculation of Reynolds number by using formula with using this given information is 0.3. So the laminar, it is a laminar flow. So far we have done some problems and solving problem as well as some theoretical questions. We have done. Please subscribe our YouTube channel.